Hello everyone and welcome to EBA Consulting very first podcast. Today we have with us Dr Alexandre Bradley, who among other occupations has been an airport systems specialist and an engineering consultant specializing in baggage handling systems as well as terminal planning. Personally, as an airport planning consultant, I feel privileged to host one of the authors of the IATA Airport Development Reference Manual. Dr. Bradley, Alex, thank you very much for joining us today to give us some insights into your areas of expertise around whole baggage screening, compressed build and batch build, and finally, the artificial intelligence in airport automatic design.
Good morning. Glad to be here and speak to you.
Before we dig deeper into our topics for today's discussion, can I just ask you how and why did you choose aviation as your specialization, as your career, as your areas of expertise? How did you end up entering this particular industry?
Interesting. I come from a history of people in aviation. My father was in aviation. My mother was an air stewardess for Air France and Caledonian Airways for about 30 years and worked at the airport authority. My father worked on bits of Concorde, and so he was a electrical design engineer. Very interesting chap. And so was my mum. It was, lots of time spent in aviation. Mum flying all over the world, and my dad sort of being in that sort of industry. For me personally, I actually started in aviation at Bristow Helicopters as an airframes engineer, doing mechanical engineering. I originally was going to do an aeronautical degree with Bristow Helicopters and do a helicopter pilot's license simultaneously. But the part-time aviation aeronautical degree became not available that year. So at the same time, I'd actually applied for a scholarship with British Airports Authority. And I was fortunate to get one of the last scholarships that they did. And they sponsored me to do a mechanical engineering degree. And it was a big deal for me because I was really interested in flying and really interested in not so much airports at the time, but more the actual sort of flying side of things and actual aircraft. And so it was a big deal leaving Bristow. I've never looked back really, and I've had a fantastic career. Very fortunate to have worked with some splendid people, very talented people, and learnt a lot and continue to be learning. So I progressed through my degree at Kingston initially, and then basically later in my life went on to Cranfield and did a master's and a PhD at Cranfield.
That's really impressive, and indeed some very, very strong background in the aviation industry, running in the bloodline.
Yeah, a little bit.
So again, thank you for joining us today. And now to set the scene for our first discussion topic, maybe let's understand a little bit better the foundations for the requirements for whole baggage screening and why legislation is used to describe them.
Obviously, there's different legislation in different countries. The overriding one is what's set by the United Nations in the annexes. Annex 17 being the security one, which is particularly relevant. It's probably the highest legislation, and it's applicable to the member states. And believe it or not, there are some big countries around the world which are not member states, so don't observe those technically. However, when you look deep at the legislation, there's very big synergies and very similarities between that and the national legislation that those larger countries sort of put in place. The US, I'm thinking. In terms of the sort of next tier down to that, arguably ECAC. Well, ECAC is obviously like the European equivalent of arm of ICAO. Many documents in there, restricted documents that stipulate what the requirements are for whole baggage screening. The ICAO 17 is quite high level. ECAC document 30 is much more detailed. They then sort of set out the very, very broad, ICAO 17 sort of sets out the very broad outline of what those requirements are, not particularly detailed, and then it's down to the national security plans and the DFTs or CATSAs, Canada, CATSA and the USA, FAA sort of TSA sort of screening programs to to stipulate how that's then interpreted from the sort of high level requirements into more practical, detailed stuff. There's also IATA, who have although not legislation, it's recommended practices, and I would say internationally probably the most frequently used best practice guidance that is commonly. I mean, every single baggage project, and I've not just worked on baggage projects, but every single sort of airport development project that of any sort of stature would use the IATA guidelines as their sort of reference point, and legal reference point as well, because it is considered to be best practice and so widely adopted, and also so widely, such a big long pedigree. I mean, it was a privilege working on some of that documentation in the early 2000s, having written some of the quite a large proportion, in fact, of the airport development reference manual. In terms of the legislation, as say there is there's a lot of detail in some of them, and some of them less so. But basic principles about in the ICAO, that those are adopted, and those all sort of changed massively after the Lockerbie disaster of the late 80s, which obviously prior to that, screening was really only done by the Americans and by El Al. Everything else was pretty much zero screening or very sporadic screening.
On the regulation, this is just something I wanted to throw in as well, because many a time have we seen that the regulation changes as a result of various unprecedented incidents that in some way or another they basically change or shape the industry as we know it. And exactly what you mentioned, one of such examples could be the late 1980s Lockerbie disaster. And could you tell us a little bit on sort of what advances in HBS system have occurred since one of those deadliest terror attacks in the history of the UK?
Yeah, I mean, I just joined BAA at the time. I was an undergraduate engineer, and I was working with a couple of colleagues, Norman Shanks, who was the security director, and Simon Gandy, who was a brilliant engineer. He's actually CEO, I think, of Sydney Airport. Basically, it shocked. I mean, that was threat profile that the UK and other nations were sort of facing was unprecedented. And without sort of going into the politics of things, it was clear that there was the capability and the willingness to create some pretty nasty sort of threats. And so the UK government, working with sort of BAA, decided they had to do something to combat that. And so there was a pilot scheme that was developed prior to Lockerbie. So pretty much, I remember even in the early 90s, before any of the sort of HBS had been sort of properly rolled out, the key sort of screening technology was no explosive detection systems. It was just basically standard X-rays, and every single check-in. You could go to the American Airlines desks, and you'd have zone A, B, right through to E. And basically it was only zone A that had X-ray machines, and everything else was unscreened. And then obviously apart from the LL flights, so you had on one sort of spectrum that sort of basic technology, which was pretty limited in its capability to deal with something, and then on the other side you had the LL stuff, which was actually quite sophisticated and actually some quite learning. And then there was new technology coming out of the States. A company called what is now L3. I think L3 bought out the rights. L3 Communications bought out the rights, but basically it was a company called Vivid, and there was a lot of activity in basically bringing that screening technology to the forefront as a response to the Lockerbie disaster. What was quite appropriate, and this was Norman's decision really, was to actually because the nearest airport that this occurred to, the Lockerbie disaster, the trial site was considered to be Glasgow as a mark of respect, and so basically all the sort of we shipped all sorts of technology from all around the world, working with the government as well, to basically detect these, find out what technology and what processes worked, and the response was say myself, Norman, and Simon. Basically, Simon developed the sort of screening strategy. Norman set the sort of requirements, and I developed the design as a relatively young engineer. At the time, I actually thought it was just another little project. I didn't really sort of appreciate at the time that it was something that was to become a whole industry. But it started off with Standard 1 in the sort of the early 90s, up through to about 2002. And then it went to Screening 2, multi-view technology, with backscatter technology. And then obviously the current screening requirement is Standard 3, which is computer tomography. And that's it.
Which eventually also made its way to security checkpoints.
Yes.
And obviously with technological advancements and miniaturization, really, it has been made possible, and we can now see that on the increase as well as a new trend, and also the regulation coming towards the UK airports. So it's really interesting to know where it's coming from, really.
Yeah, so I think what was quite interesting for me was the fact that at the time I thought it was just like a 2-month sort of project, and it just shows you that some of the things that you think when you're young and are potentially insignificant. Put my hand up and said, "Yeah, I'll help Simon." Got on very well with Simon and Norman, and did some and as I done a number of things with Norman in the past. Since then, we've written books together, and it was a privilege to work on that project. And it's probably one of the things I'm in my whole career, probably the most things that I'm glad I did.
It's an incredible story indeed, and thank you for sharing it, because not only it's relevant to the subject, but having such a personal connotation to it, it just makes it so much different. So with that historical background that we discussed, I'm also curious on what you expect the future of HBS to look like. And I think this question sort of leads us towards the current circumstances as well, and probably what puts another dimension around it is now coming from the COVID-19 situation. So
sure,
historically, we have always seen a strong recovery from the crises affecting the aviation industry, but do you think that anything will change for the UK airports given now its unprecedented scale? So if you can touch on this one, what's your thoughts? And then also sort of leading us to your expectations related to the future of HBS itself. I think it would be really good to find out.
The first thing I would say is that the technologies that are deployed at airports historically has been well tested and investigated before and had sort of field trials done on that equipment to see its validity. It's absolutely vital that nobody goes off in sort of wild directions, and that everything is done in a sort of coordinated and fact-based way. One of the things that was done very well, I thought, at the very beginning with HBS is that I remember there were sort of technologies that were claiming to do all sorts of things, and when we actually put them in field trials, it was quite apparent that they were less effective than they were claimed to be. Wildly. So field trials, tests are important, and evidence-based results of how those field trials sort of correspond to dealing with some of the issues is really important. What are those issues? Obviously at the moment, without going into too much detail, the whole baggage screening processes are in the belly of the airport. They've been placed in there following sort of last 20 odd years worth of development, 20, 30 years of development. Is there a need to do things and make people sort of feel more secure and safe? And what else can you do with that technology to combat things like COVID-19? Well, I'm a doctor, but I'm not a medical doctor. So please take my comments with the knowledge that that's there, and rather than I don't want to speculate. But I see that if there are technologies, I've come across previous technologies such as pulse neutron trials done in Australia, actually, on pieces of kit. There are certain things that you can do with that type of technology to make things, essentially sterilised. But there are negative things with that as well. There were frequencies of light that can be used, and again, all of this needs to be tested in a laboratory, then done in field trials before any sort of conclusions on anything that you can do to deploy this in airports. CT technology is excellent at providing a very thorough and very cohesive sort of threat management solution. Much more so than the previous standards of HPS technology. I think deploying it at earlier places in the airport is probably likely. Things like there used to be a scenario. There were, in the Far East, many airports used to have sterile check-in zones, and so any person coming into the front of the terminal was effectively considered to be free from or essentially threat managed. I think something similar to that, unless there's medical advances, I would say that there needs to be something that can actually manage that, so that the complexity of cleaning an airport, sterilising surfaces and things like that doesn't become problematic. That's just the airport. So end-to-end sort of journey connections and security and cleanliness. Airports have spent millions on cleaning airports, and certainly some do anyway. I think if they have a solution that can actually make that, give the confidence to the travelling public that they're entering an environment which is safe and secure, not only from sort of security threats, but also from biohazard sort of threats, then that's got to be a good thing. And that might end up being, from the car park to car park. And I think that's going to be a sort of an area where people are going to start looking at. And it could be sort of, but then you've got the aircraft itself, and seating plans in aircraft, making sure that those are dealt with in a sort of effective way is going to be a challenge. Commercial viability, almost certainly, if you remove sort of or simplify, create social segregation on flights, however you do that with the seating modifications or whatever, you then are then looking at this scenario where the air flight ticket is more expensive. I also think that governments need to look at taxes. So tax levies support the airports rather than hinder them, and give the UK airports in particular a competitive, to be able to be competitive. I mean, taxing them is not the way to do it. Giving them sort of breaks and grants is probably the right way to support them, would be my opinion, certainly in the short to medium term.
Absolutely. And even looking at any potential scenarios with the social distancing measures in place, I think it's very easy to reach the conclusion that viability of such operations may be really questionable for many airports.
I think flight ticket prices will have to increase if they're certainly in the short term, but they will always. I mean, it's a wonderful industry, and you can sort of, it's resilient, but this is unprecedented. Precedented sort of situations call for sort of unprecedented sort of reactions from the government. And so it's essential that travel is there for a number of reasons, not just business, but social and all the rest of it. But from economically, it's essential that we're put the British airports, I'm talking about Britishism perspective, but, thinking of all airports around the world, I think that probably domestic markets will probably recover the most first. Hopefully I'm wrong, if it's safe to do so. But the domestic sort of travel could be the key to opening back up the airports in a controlled manner, but with some serious subsidies on it.
Now, having covered the history and where we are now, as well as where we could be headed with the HBS, I guess let's now move on to our next topic. Could you please explain, for the benefit of our listeners, what the compressed build and batch build entail, and what made you think that the compressed build was necessary and possible?
HBS, whole baggage screening, and compressed build is more to do with flight management and ground operations management, as opposed to sort of screening. But they interact with one another, because obviously being able to process those in a timely manner and being able to restrict flows and do things as and when they're required is key to make an efficient airport. I think one of the things I go back to, you obviously can you build your sort of comments based on your experience, but over the years I've gone into airports and large, small, complex, arguably sophisticated systems, and then less so. One of the things that always struck me as being sort of outrageously inefficient was the way that bags would come into the system. Passengers would be asked typically for a long-haul aircraft, a long-haul flight to turn up 3 hours before, 2 hours for a short haul. The flight would open at check-in, and they would automatically open the back of house at exactly the same time. Now, because of the nature of my job, I would often be I'd see that frequency and occurring. You'd literally go out to the back of house to see what was going on back of house, and there were literally people, reading newspapers and over-resourced for the first sort of 90 minutes, and then under-resourced for the last remaining time of the flight open period, up to 2 hours and 3 hours respectively. Sometimes up to 60 minutes before flight, it was completely no operational, very little trickle feed, I used to call it. But you'd see these people sort of reading newspapers, and I was thinking, this is incredibly inefficient. Not only was it inefficient from a operator perspective, but it was also inefficient from a use of what increasingly over the years has become extremely valuable real estate. So I really sort of came up with an idea, which I will confess was born out of a conversation I had with a chap at Heathrow, who basically said, "Got to get this work behind us," was his comment. And it made me think, okay, so how could we get the work behind us? And the comment really sprung my ideas. Little grey cells going. Basically, the idea is that you have, with a compressed build, you have the ability to take a series of bags that are coming in from check-in, and you basically store those bags rather than feeding them out to the laterals. You screen them, store them securely, feed them up into the space where they need to be held in a process. And then rather than having flight open time of, say, 3 hours or 2 hours for short haul, you actually make that something like 90 minutes for a long haul and maybe 60 minutes for short haul. And then you think, well, what would that actually do? Can you actually make that process work? Well, actually, we did a trial at Terminal 5 at Heathrow, and it was so successful. It was so successful that by managing those flows, and actually we could actually get, I think it was 40% saving in foot space by, in makeup space on the ground floor, by actually making sure that it was almost like a just-in-time sort of philosophy. So the ULD would be delivered to the makeup area, and then they would do synchronized flows. So you pull the ULDs to the makeup area, then you pull bags from the bag store. So that you only ever were dealing with what you needed, and you weren't. And so there was no sort of like 1 or 2 bags on a MUP area that could do with maybe 300 or 400 bags. It was just in time sort of delivery, factory type technology. It was incredibly successful. That sort of set the scene for, basically was it got right. I saw that the 11th edition of the IATA manual, and I put it in my airport planning book, my own one, the Independent Airport Planning Manual, back in 2009, 2010 when I wrote it. Compressed build, I said it would be, successful, and it is now the recommended IATA process. So good. And I think the only thing I would say is one has to be extremely careful that workforces are not excessively overloaded, and they're provided with the right tools, and the ergonomics are correct. And because it's having worked on those areas, just to experience it. Because it is really good, to go down and work in these spaces. These guys and girls that work in those spaces, it is back-breaking stuff, and so you have to give them the right tools. So it's one thing saying they're reading papers, but they might be actually taking rests. So you have to balance that and make sure that the space and the environment is safe and sustained. And the way to do that is by providing them with the right sort of handling aids, so that they are not hurt. and that they actually, 20 years of life working in that environment, can go home safely to their families.
And from your experience on this one, I think it's a very relevant and valid point here. Can you tell us what's the staff acceptance on this one? Because from our experience at EBEA and what we do, obviously we provide management consultancy on how to increase efficiency of the processes in many various ways and how to optimize the operations better. However, what the management may perceive as an efficiency gain, that may not necessarily be understood in the same way by its employees. So how did the staff respond to the change of SOPs and decrease in downtime?
That's interesting. My experience of doing it in a couple of airports is that it's seen as a threat initially. You have to have someone that's really, really good at communication, and you have to have a good story to tell. It's fact-based story, because it's it has to be true and correct. But basically, one of the things that certainly, generally, I would say, younger staff saw it as an upskilling opportunity. Rather than lugging just bags around, they were being trained to use robots or handling aids, service handling aids, operate handling aids, and not feeling so exhausted at the end of the day if they hadn't. So there was communication trialing was really important to get buy-in. Also, there was a absolute clear strategy that as expansion of the systems came, they would be mapped to basically making sure that there was no job losses. So it was natural wastage. So if there was, you'd always offer a plan to upskill somebody, and that was met very well, I thought, and a clear, concise, and honest portrayal of the natural wastage schemes. And as people retired, their position might not necessarily get replaced. And then the automation would cut in on the phase of growth automation. The selling of it is equally as important, because you can bring an airport to a complete standstill without the correct buy-in, as I'm sure you know.
Absolutely so. And I think it also touches on the very important trend that fortunately seems to be on the rise nowadays, which is trying to match the efficiency gains with also increasing the employees' well-being, and fortunately more and more organizations are taking care of that as well. Have you also noticed any other changes in terms of the operational KPIs? So you did mention that it has been extremely successful in terms of the space efficiency and obviously the timing of the operation, but is there anything else that would be especially prominent with adoption of this approach?
Absolutely. Whilst there's an increase in some automation like bag store sophistication and the bag store sizing, because you still have the size and store that equipment, the resultant buildings actually become sort of like 35-40%, if done correctly, 35-40% sort of more efficient. So you have a smaller footplate. So you're heating it less. So energy consumption is considerably less. You need less staff, which means less car parks, which means less people coming in by car. So environmentally, it's sort of like, snowball. Energy consumption, CO2 emissions are all tangible sort of KPI benefits that you can get from it. Also, the other thing, which is you can do things like in-system time can be it's a different measure, because historically it would be, if you look at the original IATA or 9th edition IATA, it would be sort of from check-in through to the latest MUP. Whereas in a compressed build system, you might store stuff for 20 minutes, 30 minutes, an hour, and so there's a different sort of metric there. And in terms of sort of fast tracking and processing, I think the other thing, which is probably not well understood, or certainly is a tangible thing, is that some of the more sophisticated systems, what used to happen is you'd get you take a weight from check-in, and that would be translated onto the barcode information, and then there'd be categorizations of the weight of the bag that were actually going into the hold, and then there would be a relatively manual calculation of the weight of the articles that are inside the URDs. With the dynamic weighing conveyor equipment, you can actually get a pretty accurate representation of what the actual weight is of the bags. And so when the bags go into the batch build and release build pulses that go out, then basically you can actually put the heavy bags at the bottom of the containers to make them more stable and more secure. And also you can control precisely what the weight limits are, so that when the captain of the aircraft is then doing sort of assessment of the weight and balance of the aircraft, they're not making guesses that the actual aircraft are flying through the sky probably a lot less trim.
In terms of the acceptance of this solution among airports this time, is there any significant difference between, I'm interested to learn, between larger versus smaller or regional airports? Are there any drivers behind the size of the operations and the scale of it? And also, would there be any distinction in terms of its attractiveness between point-to-point versus hub-and-spoke airports?
Yeah, that's an interesting one. I think the hub and spoke is clearly, I mean, the transfer market has definitely got because transfer bags often went into early bags. What they didn't do is they were previously crudely leaving sort of flight open times relatively long. Now it's much more controlled. So you have like a 90-minute or a 120-minute slot, which frees up a lot on the ground floor, which makes, some of these more site-constrained sort of sites much more viable. The value of the land is much more valuable than, say, a relatively open field small airport. Not always, because I mean we both worked, I think, at airports where they could be constrained and be small airports, and the value of the land is equally, if not more, valuable. I think real estate value is a key metric. I would say, generally speaking, the smaller the airport, the less likely it would support compressed build. However, the technology, I mean, we've just finished designing stuff for a small airport, category B, IATA category B baggage system, and that has a compressed build capability. And not that sophisticated, just deploying equipment differently, and that has got a massive capability. Equally, you can go to the sort of Amsterdam's Terminal 3 IB. I mean, the baggage factory at Terminal 3 was the second airport in the world that had the robotics. Not that I'm too impressed with the robotics, but the compressed build and batch build capability at Terminal 3 is probably second to none. That's a large airport, obviously, and maximizes the capability of the use of compressed build. Absolutely. I'm so successful that it is basically the benchmark for what I would consider to be IATA category B and C baggage systems. And in fact, that's been replicated and echoed in the IATA version 11 document, which stipulates the sort of process that came up with back in 2009-10. Which is also in my book.
Impressive. I'm pretty sure we will be very happy to share all the literature that you have been involved in, and perhaps in the description of our podcast we can do a little bit of recommended follow-up readings on everything that we have been talking about so far. And now, this is the end of the first part of this interview. So thank you for listening, and make sure that you tune in next week when we will continue to talk about artificial intelligence in airport automated design. Thanks again. Bye-bye.